contents, and getting started. Congratulations and thank you for purchasing your Mala Easy Locator HDR. You have purchased the #1 selling GPR system dedicated to the detection of utilities in the world for over a decade. Before you get started, there are a few things you need to know to be successful in the field and enjoy many years of successful operation. Upon arrival, please be sure to inspect the packaging for any damage that may have occurred during shipping. RTC cart. Your Easy Locator comes standard with built-in wheels that can handle most urban environments with ease. However, in some circumstances, the terrain may not be conducive to this configuration. Mala developed the Rough Terrain Cart, or RTC, to handle just about any terrain normally encountered for GPR surveys, and is the most commonly preferred configuration of the Easy Locator HDR series. Receiving your RTC. If you have ordered the RTC option for the Easy Locator, you'll receive 2 boxes when your shipment arrives from Mala. The larger of the 2 boxes contains the RTC cart. After opening the RTC shipping box, you'll find necessary parts to assemble your RTC. Some parts are shipped in a separate plastic bag. Specifically, the following parts are included: assembly instructions, parallel data cable, Velcro, axle washers, axle bolts, a spare clip, encoder coupler, monitor knobs, encoder bands, spare axle clips, Allen wrench, 4 solid tires with axles, handle post with monitor platform, cart frame, assembly of the RTC. Begin by removing the Allen wrench. And install the optical encoder at the left rear wheel position. Be sure the small encoder coupler is toward the outside of the cart. Place encoder gear through the axle and into the spokes of the tire for a secure fit. Wrap the encoder band around both the gear and the encoder affixed to the cart while inserting the axle into the pre-drilled hole on the cart frame. Secure the wheel to the cart frame with the axle bolt tightening with the Allen wrench provided with the RTC. Repeat this step for the remaining wheels. After all 4 wheels are attached, check to see that the handle post hole is clear and the post pin is in the open position. Insert the black handle post base into the hole on the cart. Snap the post pin to the closed position, and both the pin and the post are secure. Tighten the 2 screws to secure the handle assembly and adjust the monitor plate by pulling the tab and adjusting the position. Finally, adjust the straps on the skid plate just above the surface of the ground. System assembly. The second box contains the Easy Locator components. In the box, you'll find the following system components: antenna, monitor, charger, battery bag, 2 12-amp-hour batteries, 1 power cord, 1 PowerCom cable, Mala software and manual USB. To integrate the Easy Locator HDR system components with the RTC cart, begin by sliding the antenna into the front of the RTC. Make sure the PowerCom cable is located in the front of the RTC. Attach the encoder cable connector from the RTC to the rear of the Easy Locator HDR antenna. Do not over-tighten screws. Attach the monitor knobs to the back of the monitor. Leaving a gap large enough to slide the monitor into position on the platform by aligning the knob shafts with the slots on the platform. Secure the monitor by tightening the knobs. Attach the battery bag with grommets located on mainframe handle post brace. Insert the 12 amp hour batteries into the battery bag and connect the batteries to the Easy Locator cables provided in the bag. Plug one power cord into the rear of the battery adapter and the other end to a port on the outside of the battery bag. Zip the battery bag closed to protect the batteries and connectors from direct exposure to dust and moisture. Connect the PowerCom cable to the front of the battery adapter and the other end to the monitor. Neatly secure all cables to the handle post with the Velcro straps provided. Velcro is provided to be placed on the bottom of the antenna to keep the antenna secured on the cart skid plate. Power on your system and you are now ready to collect data. To activate your warranty, log on to the Mala website and register your company. The serial number for your system is referenced by the serial number on the label affixed to the top of the antenna. Assembly. After removing the unit from the box, carefully remove all packing material and remove the Quick Start Guide. This guide is a handy reference, and it is recommended that you maintain accessible copies for all users. Next, remove the battery compartment cover. Inside, you'll notice 4 battery cables. 1 to 4 batteries can be connected, depending on how you manage charging and battery changes in the field. Next, take the small power cable and plug the black 2-prong connector to either one of the 2 power receptacles at the back of the battery box. Then plug the silver connector with the red dot up into the receptacle on the back of the battery power adapter. Replace the cover securely back onto the battery compartment. Next, raise the handle assembly to the upright position. Secure the handle system with the metal fasteners on each side of the handle assembly. Check that the 9-pin encoder cable is securely connected to the 9-pin connection at the back of the antenna. Your Easy Locator features adjustable wheel heights to allow for operation on varying types of terrain. Your unit may have arrived with the wheels in the lowest position. Adjust the wheels to the desired position by pulling on the pin assembly located at the midpoint of the antenna and simultaneously lowering the height adjustment lever. Plug the PowerCom cable with the red dot up into the receptacle on the monitor and the other end to the receptacle at the front of the battery power adapter. Charging your Easy Locator HDR. Be sure and charge your Easy Locator HDR batteries upon arrival from Mala. To charge your Easy Locator HDR batteries, simply remove the lid to the battery box, or unzip the battery bag and remove the batteries. Plug the battery into the battery charger. And then plug the charger into the wall. Next, disconnect the power cord from the rear of the charger to reset the internal memory of the charger. Each battery typically maintains a charge for 2.5 to 3 hours of continuous operation. It's always a good idea, however, to charge the batteries after a day of field work. A red light on the charger indicates that the battery is charging, and a green light indicates that the battery is fully charged. Charging time is typically 2.5 to 3 hours per battery. Caution: to protect the charger electronics, it is critical to plug the battery into the charger before plugging the charger into the wall. Damage to the charger may occur if this precaution is not adhered to. Powering up and booting. To power up the unit, press both the power button on the battery power adapter and the power button on the monitor. Both LED red lights will remain steadily illuminated. The monitor will perform a boot sequence, and you may notice several text messages on the screen. This will last about 30 seconds. Your Mala Easy Locator HDR has a user-friendly interactive screen. Commands are entered with the control knob by simply rotating the knob and highlighting the icons on the screen. To activate the submenus, simply push the knob. Screen overview. The screen is designed for ease of use in the field and displays certain information at startup. The top of the screen contains the horizontal distance scale and vertical scale on the side, which can be set in either feet or meters, which you may choose and is discussed in another segment of the video. On the right side of the display, you'll see high visibility icons that are selected by rotating and pressing the control knob. At the upper right of the display, the circle with the cross is the GPS strength indicator. A gray color indicates that no satellites are being detected. A yellow color indicates that some satellites are being detected. And a green color indicates that the maximum number of satellites are being detected. Please note that the Easy Locator HDR unit should be powered up outdoors with a clear view of the sky. This will ensure that the GPS unit begins to detect available satellites. The battery status indicator can be found to the right of the GPS indicator. The color bar indicates battery strength. Green indicates high charge. Yellow indicates medium charge. And red indicates low charge. Each lithium-ion battery should last approximately 2.5 to 3 hours. Up to 4 batteries can be connected to the small wheel HDR unit, as well as the battery bag on the rough terrain cart. However, only 2 batteries are required to power the system. The following icons will be seen in the acquisition screen prior to beginning a survey. Please note that the functionality of these icons will be described in more detail in another section of this video. Quit. Start. Camera icon, if screenshot option purchased. The wrench icon, or Tools menu settings. Full screen. Background removal. Contrast. Time gain. If auto gain is selected, then this icon will not appear. The following icons will be seen in the acquisition mode. Stop. Camera icon, if screenshot option is purchased. Hyperbola fitting tool. GPS marker, if GPS marker option is purchased. Full screen. Background removal. Contrast. Time gain. If auto gain is selected, then this icon will not appear. Once in the acquisition mode, you'll also notice a scroll bar at the bottom and the right side of the data screen. The scroll bar on the right side of the data screen is the zoom control, and the scroll bar on the bottom of the data screen is for scrolling through a data set. This topic will be discussed in more detail in another section of this video. Other important settings displayed are 1. Soil velocity in feet per microsecond or meters per microsecond. This is an important setting and controls the accuracy of the depth to the desired target. We will discuss techniques to calibrate the depth scale in another section of this video. 2. The antenna frequency is automatically detected, which is designated as HDR mid or 450 MHz. 3. Trigger type, which indicates the direction the surveys will be collected and the type of cart being utilized. On the small-wheeled Easy Locator, select either internal forward or internal backward. On the rough terrain cart, select either RTC forward or RTC reverse. Time mode can be chosen, which does not require an encoder and will pulse at a given time interval. This will be discussed in another section of this video. Changing settings for operation. The first thing you want to do is set up the Easy Locator for data collection in light of the anticipated soil conditions and depth of interest for your area. Simply highlight the wrench icon and push the knob to reveal the Settings menu. The first setting you may adjust is the color scheme for the data. The three options are Gray, Color Scheme 1, Color Scheme 2. In most conditions, grayscale is sufficient and gives the best results in the field. Some targets may be illuminated or highlighted better with the color scales. It is essentially a personal preference of the user. The next setting adjusts the screen brightness. This value is generally set to 100%, which is the maximum. The next setting is soil type. This setting is important since this is the controlling factor for the system to display depths reasonably accurately during data collection, since soil moisture generally determines the velocity of the radar signal in the ground. At this time, the default setting is typically 300 feet per microsecond. This setting is not critical at this time, since later you will learn how to calibrate the velocity during data collection. Acquisition mode determines how you will be collecting the data as you move the Easy Locator HDR. Forward means you will collect data as the Easy Locator is pushed along the ground in a forward motion. Most all applications are handled in this mode. In some instances, it may be easier to pull the Easy Locator, particularly in thick turf grasses or loose sandy material. Simply select Reverse, and data is collected as the unit is pulled backwards. In extreme terrain conditions where the wheels do not make constant contact with the ground, time triggering is used. Please note that in this mode, there is no horizontal distance information displayed on the screen, since the odometer in the wheel is not in use. The distance scale is replaced with a time scale. Settings for the rough terrain cart options are also displayed as RTC forward and RTC reverse. System parameters. Selecting System Parameters opens the Operating System menu, where the following can be adjusted and set. Time and date. To set the time and date, press the black control knob to highlight the time and date window. Rotate the control knob to position the small white triangle pointer underneath the value to be changed. Press the control knob once again, and a small triangle will appear above the value to be changed. Rotate the control knob to input the correct value. Then go to the next value to be changed and repeat this procedure. Upon completion, rotate the control knob and position the small triangle underneath the large triangle and push control knob to exit. Battery max level. The default value is 11 and does not need to be adjusted. Power save mode. The default setting is OK and should remain on, as it reduces power consumption when the system is idle for a period of time. Imperial, or SI. This setting allows the user to display units in either imperial, displayed in feet, or SI, which is displayed in meters. Language. The Easy Locator HDR accommodates up to 11 languages for the user interface. Select the appropriate language for your region. To save your language preference, the user must select Save and Exit. The system will reboot with the reflected changes. Hardware test. The hardware test is a diagnostic tool in the event the Easy Locator HDR does not function properly. It is typically used during technical support to aid MALA technicians to troubleshoot the system. Data disk format. The data disk format is used to reformat the SSD radar data storage device. See manual for further recommendations. Software upgrade. MALA GeoScience periodically releases software updates and upgrades for MALA Easy Locator HDR. Installing these updates allows you to take advantage of the new features and improvements that increase performance and system availability. Log on to the MALA website under Service and Support, Software Downloads, and upload the latest firmware to an empty or blank USB device. Plug the USB device into the USB port on the monitor and select Software Upgrade. The software will then be uploaded to the monitor. The system will then reboot. Restore predefined settings. This selection is used at the discretion of MALA technical support personnel during troubleshooting in the event the Easy Locator HDR experiences a problem. Restore factory settings. This selection is used at the discretion of MALA technical support personnel during troubleshooting in the event the Easy Locator HDR experiences a problem. Warning: this option should only be used as a last resort when the Restore Predefined Settings option fails to solve the issues that you are experiencing. Next screen. Depress Next Screen to open System Menu, Screen 2. In Screen 2, the user can adjust the default zoom depth of the system. The default zoom depth simply defines the range of depth window, or the maximum depth range a target may be detected. Please note that this scale is dependent on the soil velocity setting. In a later segment, soil velocity calibration procedures will be covered. Also, the depth window maximum does not necessarily mean quality data is achievable to that maximum. Soil conditions vary greatly and affect the maximum penetration of GPR signals. Time gain. The time gain button is used to adjust the time gain for the GPR profile. The control knob is rotated to increase or decrease the applied time gain. The user may select either manual or auto by depressing the control knob. Soil conditions dictate which mode is most effective. Auto gain amplifies the signal with coefficients that balance the signal throughout the radargram. Manual gain is used to manually amplify the time gain on the GPR profile. Time interval. Time triggering, which is found in the Acquisition Mode menu, is selected and the user can adjust how many traces or pulses per second are generated to collect data profiles. The default of 0.100 seconds is normally adequate. GPS parameters. Your Easy Locator HDR comes standard with a built-in DGPS receiver if option purchased. The system is also compatible with external GPS systems of the user's choice. The external GPS devices may be connected either through the COM port or USB port as determined by the GPS manufacturer and model used. To access the GPS option, select the wrench icon. Then select System Parameters. Then select Next Screen. And finally, GPS Parameters. Select by toggling between built-in, USB, or COM. If COM or USB is selected for an external GPS receiver, default settings are normally adequate. For additional instructions on connecting an external GPS receiver, please refer to the MALA Easy Locator HDR manual and the GPS manufacturer's manual. For built-in optimal accuracy, select WAAS for U.S. customers. And for regional coverage outside of the U.S., consult the manual for the appropriate GPS coverage using the SBAS region menu. After selections, select Save and Exit. Then select Previous Screen. Then select Save and Exit. Then select Save, which will return you to the acquisition screen, at which time you will see the GPS coordinates appear on the bottom of your screen. Options. Selecting Options displays both the serial number and the current software version of your Easy Locator HDR. The additional software options available for purchase are Screenshot Capture and GPS functionality, and are activated by entering the appropriate code provided by MALA at the time of purchase. Please note that these options can be added at a later time. Once GPS and screenshot options are activated, the camera icon appears as a menu item in the acquisition screen. When in the collection mode, the GPS marker icon appears. While collecting data, the operator chooses to take a screenshot of the data on the screen. Turn the control knob and select the camera icon. This will create a JPEG of the data on the screen. If a target is identified and the operator chooses to place a GPS mark above the target, then turn the control knob and select GPS marker. This will place a GPS mark on the data. These two options will be discussed in greater detail in another section of this video. Using your Easy Locator. The first thing you want to check in the main screen is to ensure that the settings are properly displayed. For example, the soil velocity, antenna frequency of 450 MHz, and the trigger type selected by the user. To start collecting data, turn the control knob to highlight the Start button and push the control knob. The first thing you'll notice is that the radar screen turns black. Push the Easy Locator and you see data appear on the screen scrolling from left to right. If both screenshot and GPS marker functions are activated, the corresponding icons will appear, and if GPS coverage is adequate, the DGPS coordinates are displayed. While collecting data, there are 6 icons you may select. Stop, camera icon if this option is purchased, hyperbola depth calibration, GPS marker if this option is purchased, full screen, background removal filter, linear gain or contrast, exponential gain. If auto gain is selected, this icon will not appear. Stop. Selecting Stop discontinues data collection for the current profile. Starting a new profile will erase all previous data. Camera icon. If the screenshot option is purchased, then turn the control knob and select this icon to take a screenshot of the data on the screen. A JPEG image will be saved and can be retrieved at a later time. Hyperbola calibration. To calibrate depths to targets during data collection, the hyperbola matching calibration method is used. To calibrate, perform a scan over a target exhibiting a hyperbola. Ensure that the scan is as close to perpendicular to the utility as possible for accurate calibration. Pull the Easy Locator HDR back over the target, and you'll notice a vertical cursor or line appears in the data profile. Align the cursor or line at the midpoint of the target utility. Press the control knob, and a horizontal cursor or line appears. Scroll up or down by rotating the control knob clockwise or counterclockwise, and center the cursor or line at the top of the target utility. Depress the control knob once again, and the default or previously saved soil velocity appears, as well as a theoretical hyperbola over the actual data hyperbola. To properly calibrate to the data hyperbola displayed, rotate the control knob clockwise or counterclockwise to match the theoretical hyperbola to the data hyperbola. Note the value for the soil velocity and the depth scale changes in real time during the hyperbola calibration. When the hyperbola fitting operation is complete, press the control knob to eliminate the soil velocity value above the theoretical hyperbola and begin pushing the unit forward until the Easy Locator HDR unit reaches the previous endpoint on the data profile, and data collection will continue. The updated soil velocity appears at the bottom left of the monitor. To continue data collection, push the Easy Locator HDR forward. Data collection will resume once the cursor or line reaches the previous endpoint on the data profile. If the screenshot and GPS marker options are activated, an additional two icons appear as the camera icon and GPS marker icon. The functionality of screenshot and GPS marker will be discussed in another segment. GPS marker. If the GPS marker function is active, the icon appears in the data collection screen. To mark a utility and tag its corresponding GPS coordinates for later export, pull the Easy Locator HDR back over the desired target. The vertical cursor or line appears in the data profile. Depress the control knob to tag the GPS marker to the target utility. A blue dot and marker ID number appears at the horizontal location of the target utility. To continue data collection, push the Easy Locator HDR forward. Data collection will resume once the cursor or line reaches the previous endpoint of the profile. Refer to the Mala Easy Locator HDR manual for downloading and display of GPS markers in Google Earth. Full screen icon. This command removes the menu icons and displays a full screen of data. To return to the screen with the menu icons, simply depress the control knob. Background removal filter. Highlight the background removal filter and press the control knob. The filter is designed to remove unwanted horizontal bands of noise, which is endemic to most radar data. One word of caution regarding this filter is that any data that is horizontal in nature, such as soil layers and/or tracking parallel to a pipe, may result in these features being removed from the radar data. Screen contrast. This function is very sensitive, and very small adjustments make a large difference in the contrast of the data. The triangle in the icon indicates the level of contrast you have selected. One should not overuse the contrast, since over-contrasting can make the data unreadable. The following is an example of data with too much contrast applied. This is not enough contrast, and this is just about right. Time gain. The time gain function is similar to the contrast. However, the gain amplifies targets to a greater level the deeper they are. This prevents overgaining the data in the near surface, where less gain is needed to enhance targets versus those at depth. As with contrast, you can overgain the data with the same detrimental effect, so optimally, you should try to balance the images. Please note that if auto gain is selected in the system menu screen too, the exponential gain icon does not appear, as this is automated. Zoom function. Although you may have set the default zoom depth to a particular value, a powerful zoom in or out function is active during data collection. To access the zoom function during data collection, turn the control knob until the vertical scroll bar is highlighted in yellow. Push the control knob once, and the vertical scroll bar will turn blue. Push down and turn the control knob to zoom in or out. Rotate the control knob clockwise or counterclockwise to either zoom in for shallow detail or zoom out to a maximum depth range up to 20 to 25 feet, depending on the soil velocity calibration. To deactivate the zoom function, press the control knob once and the vertical scroll bar turns yellow. Turn the control knob again to return to the icon selection menu. In the field. Your Easy Locator HDR can be used over grass, bare soil, asphalt, or concrete. If ground clearance is a problem and you have a lot of forward resistance, raise the antenna to the highest setting. It is okay if the antenna makes contact with the ground. All antennas are shipped with a replaceable, durable skid plate, which is generally good for 1 year of normal operation. Contact your MALA distributor for more information about replacements. Detecting and tracing targets. Once a potential utility is detected on the screen, one can use the powerful backup cursor feature to pinpoint its location. Simply pull the Easy Locator HDR backwards towards the target detected. A cursor appears on the screen, which then scrolls back to the point the utility was detected as you move backwards. Split the target, whether a hyperbola or other shape, with the cursor. Mark the ground using the arrows on the side of the Easy Locator HDR. To confirm this is a possible utility, move the Easy Locator HDR over a few feet and perform a new scan. Repeating the process in this manner confirms that the object is a linear feature traceable underground. For clearly identifiable targets, you can actually trace the feature by turning your Easy Locator HDR parallel and directly over the target, and walk along it with slight S-turn deviations. Notice that the pipe now appears as a linear feature on the screen. This pass shows a pipe crossing at an angle of 90 degrees or perpendicular. This pass over the same pipe is at 30 degrees. Notice the hyperbola looks bigger and wider or flatter, even though it is the exact same pipe. Many times, due to soil conditions or other factors, targets may appear in a variety of shapes and are much harder to discern. Regardless, a keen eye and a technique of repeating transects every few feet or on a prescribed grid is the best way to sort out a legitimate target in less than ideal data. Time triggering or data acquisition. In some circumstances, such as rough terrain or very tall grass, the wheels of the Easy Locator HDR may not contact the ground sufficiently to use the internal forward or internal backward settings. In time mode, the unit scans continuously whether the Easy Locator HDR is moving or not. No distance information is provided. Notice the top of the screen is in time units rather than distance. In this mode, no backup cursor function is possible. To mark a utility, you must move repeatedly over the target to get a good fix on the location for marking. Time triggering may also be used in the event that the encoder fails and may be used as a backup until the encoder is replaced. FAQs. Why are there not additional antennas for the Easy Locator HDR? The Easy Locator HDR comes with a 450 MHz shielded antenna and produces usable frequencies with performance similar to dual frequency systems. Can the Easy Locator HDR find objects other than utilities? Your Easy Locator system is capable of finding many types of targets in the ground. In the course of your operation of the Easy Locator HDR, you will notice a myriad of objects detectable in the ground. For example, this is a buried loading ramp from a former truck docking station. The following are underground fuel storage tanks. Can we tell which utility is water line versus a gas line? No, not unless we can trace the pipe or line to a valve or some other visual expression of the utility on the surface. Is there a way to confirm a horizontal band type object is a utility? Yes. Just collect data over the same spot perpendicular to the last scan. Also, you could make S-turns along the profile, and you can see how the image appears to fall off as you move away from the pipe. A continuous horizontal layer, like from a soil horizon, will not behave this way. One note of caution: if you use the background removal filter, you may in fact remove important horizontal data you need. Is there a way to calibrate for depth other than using the soil type estimation? Why, yes. One of the most effective ways is to scan over a known target that has either been excavated or probed, or some pipe that can be accessed in a catch basin or manhole. In this case, we simply scan over the pipe and then measure with a steel tape or other device to the top of the pipe. Perform hyperbolic calibration and manually adjust the soil velocity to match the depth to the top of the utility. It's that simple. Be aware that this is a point measurement, and this setting may not be relevant to the entire site. Soils can change rapidly over a very small area, particularly if it is disturbed. What do other types of objects look like? Going over steel objects or wire on the surface can look something like this. Note, it is impossible to look through metal objects such as manholes, shallow buried steel storage tanks, or any other metal mass. Other objects such as steel rods, vertical in the ground, may also appear to ring down, such as in this image here. Large pipes may give you a double hyperbola or multiple images. This may be the result of getting a reflection from the top of the pipe and the invert on the inside, since in the case of concrete, we can see through the pipe, particularly the top, in many cases. Also, a phenomenon known as signal multiples may cause an exact duplicate or triplicate of the image at regular intervals deeper in the scan. These multiples will be aligned exactly one over the other. Can we see utilities under other utilities? It is possible if there is a slight offset. If a utility is directly over another utility, the lower utility may not be seen, as the radar wave will reflect off of the upper utility. Can we find a 1-inch pipe at 10 feet? Why or why not? Small pipes may be undetectable with your Easy Locator. There are physical limits to the detection of pipes based on the transducer frequency and the size and depth of the object. In general, small air or gas-filled pipes can be more difficult to detect than water or fluid-filled pipes, since they have greater contrast with the surrounding material. How do we integrate the Easy Locator HDR with the overall project objectives? The Easy Locator HDR is very powerful in that you can cover large areas and find unknown utilities or suspect utilities that lack any surface expression. One way to integrate GPR with the standard radio frequency method is to scan with the GPR and identify potential utilities. If you suspect an unknown utility, you may want to attempt to use the induction method and determine if the target can be traced. This is very strong evidence that you have found a utility. GPR can, in many cases, discriminate two or more closely spaced conductive utilities that with conventional electromagnetic techniques result in bleed over and the misidentification of two or more utilities as one. Does GPR work everywhere? This link is a good start to ascertain the general performance expectations of GPR in your area. Safety tips. Please make sure you follow all rules and regulations prior to conducting any survey regarding traffic control and attire that is required for working in right-of-ways or any industrial facilities.